All right, guys, welcome back to the second part 2 of the spinal cord video, and this is going to be the tracts. So what I'm going to just talk about here first is, and we'll do, blue will be sensory, I think. Blue will be sensory. So let's talk about the difference of that real quick. So first, you have sensory tracts. And then, okay, let's start all the way over. So what is a tract? A tract is a axon that is in the central nervous system. If a nerve is in the peripheral, if a axon is in the peripheral nervous system, then it is called a nerve. That is why you have cranial nerves, spinal nerves. But when it's an axon in your spinal cord, it is called a tract. So let's start there. So you can have a tract that is sensory. So something touches your skin, that message gets sent up to the brain, and then you sense it. Another name, since it goes up, it is ascending. And then one last name that they could say is afferent. So sensory, ascending, afferent, it all means the same thing. So what is the motor equivalent to that? So motor, and then that is, I want to move my arm, so a message is going to start from my brain, send that message down, and then it moves whatever muscle, boom. So that is going to be motor, or another one is descending, because it's starting from the brain going down, descending. And then you have the opposite of afferent, which is efferent. So yeah, let's start there. We started, boom. So let's move on. Now, there are two main, and we're only going to be talking about the three main tracts. DCML, spinal thalamic, and then corticospinal. Blue is going to be sensory. So we have DCML, and then spinal thalamic, or ST, and then we have corticospinal. So these are the big three. We're going to keep it relatively simple, and that way you guys can fill in the blanks as we go. I'm not going to be drawing like the anatomical structures themselves. I'm just going to mention it as we come up. So let's talk about DCML first. So DCML, it is a sensory tract. It is a afferent tract. It is a ascending tract. So it starts from the body. So we have to have a sensory nerve ending, and then it is going to come in through the dorsal root ganglia. So that's where the first order neuronal cell body is for DCML, and then it is going to go. It is going to go into the dorsal column, and then it is going to travel up, and then it is going to synapse with the second order neuron. So this is the first order neuron. So first order neuron, and then it synapses on the second order neuron, crosses, and then ascends up. So this is the second order neuron. And then where did the first order neuron synapse on the second order neuron? That is going to be at the nucleus cuneatus or gracilis. And we'll talk about that in just a minute. And fact check how that is spelled, because I don't know, frankly. And then the third order neuron, the second order neuron is going to synapse on the third order neuron, and then it is going to end up at the primary sensory cortex, or another name for that is the post-central gyrus. Okay, and then where does the second order neuron synapse on the third order neuron? It is going to be the thalamus, specifically the ventral posterolateral nucleus. So yeah, there we go. Now, also, where this travels up is going to be, so this is the dorsal column, and then specifically it is either going to be the fasciculus, Probably spelled wrong. Fact check it. Cuneatus or gracilis. And I actually have a model to help us with this, but so it depends. So what does it depend on? So cuneatus it depends on where it is coming into the spinal cord at. So if it's cuneatus, it is going to be thoracic, cervical and thoracic areas, and then gracilis is lumbar and sacral. And then the fasciculus is the same way. Cuneatus is cervical and thoracic, and then gracilis is lumbar and sacral. So let me grab the spinal cord model here. Okay, so this is going to be your dorsal columns, right? The first, and this one's not super great just because it's not divided, but if you're located medially, that is going to be the fasciculus gracilis, and then the one that is more in the periphery, that is your gracilis, your cuneatus, fasciculus cuneatus, fasciculus gracilis. Yeah, I mean, that's just what it is. So that's the stuff. That's everything for DCML. Also, I should have mentioned this before, but what kind of sensory information does this pick up since we have two main sensory tracts? DCML is going to be your detailed touch. So detailed touch, what does that mean? So that's going to be fine/light touch. That's going to be 2-point discrimination, and then also vibration, and then just pressure in general, like pressure. So detailed touch. When you see DCML, you should think detailed touch. And then the other thing, what does DCML stand for? Dorsal column. Okay, that's where the first order neuron travels up to synapse on the second order neuron. And then ML, I actually didn't mention that. Why didn't I mention that? So the blue dashed line right here is, maybe I did. The blue dashed line is the midline. So this is coming from the right side of the body. But remember, if it's coming from the right side of the body, it's going to be processed by the left side of the brain for the most part. And DCML is true. But where does it cross? It crosses in the mid to upper medulla, specifically at the via the medial lemniscus. So DCML, it comes up through the dorsal column and then it crosses via the medial lemniscus. Okay, so DCML, we've got that covered. Good. Make sure you know where the different neurons synapse on each other, and then definitely know where it crosses for all of these. Okay, so spinophalemic. So it's sensory, ascending. It goes up to the brain. So it's going to go up. You're going to have the dorsal root ganglia because sensory enters through the back, and then it is going to enter the spinal cord. And unlike DCML, spinophalemic, it is going to cross immediately. So if this is the midline, it is going to cross at the level of the spinal cord. Now, it's not immediate. It's technically 2 to 3 levels above. But for right now, let's just say at the level of the spinal cord is where spinophalemic crosses. It is then going to ascend through the anterolateral. And then some textbooks will tell you that there is actually a anterior or ventral spinophalemic tract and then a lateral spinophalemic tract. As long as you know that it kind of runs anterolaterally, you're fine. And then it is going to come up. Oh, also, there is a synapse moment here, and I wasn't going to draw it for you, apparently. So the first order neuron is going to synapse on the second order neuron. So the second order neuron is the one that crosses the body. And this is going to be in the dorsal gray horn, but it's going to be at a specific area. Dorsal root ganglia, that one's right there. And that is going to be the substantia gelatinosa. And what you need to know is that that is in the dorsal gray horn. Okay, so it travels up. It is then going to synapse. The second order neuron is going to synapse on the third order neuron. So this is the third order neuron. It is going to synapse at the thalamus. Okay, that's just like DCML. It's specifically at the ventral posterior lateral nucleus, just like DCML. Wonderful. And then it goes to the primary sensory cortex to then be developed or understood by us, just like DCML. Interesting. Okay, so what kind of sensory information are we looking at here? So spinal thalamic is going to be, also this crosses, at the level of the spinal cord. And there's a term for that. What is that? I have to cheat. This is awful. Let's see. Oh, the anterior commissure. Anterior commissure, come on. Well, that's all right. Since I forgot, that means you guys aren't allowed to. So the anterior commissure or the anterior white commissure. And so what kind of sensory information is this? This is going to be, so if DCML was your detailed touch, this is going to be your crude touch. So crude touch. And then this one is an older, like evolutionarily speaking, older tract. So this also does pain and temperature. And then how most people will end up testing this is sharp, dull. So yeah. So, and this should kind of bring you back to like testing dermatomes. Why do we have to do, light touch or like, just a tight little paintbrush type stroke versus, a pinprick? Why do we have to do two different things? Well, that's because we have more than two sensory tracts, but we have two main sensory tracts and they cross at different levels. DCML crosses in the brainstem, and then spinal thalamic crosses at the level of the spinal cord. Okay, so that's good. That's good there. Last one. So we covered both sensory or slash afferent slash ascending tracts. So let's talk about our corticospinal. So corticospinal, it's red. That means it's motor. So we are going to start at the primary motor cortex. That's where the neuronal cell bodies are on the outside of the cerebrum. Specifically where? At the precentral gyrus. That's the anatomical name. The physiological name would be the primary motor cortex. It is then going to come down. It's going to travel through something called the internal capsule. And then it is going to come down. And then most of the fibers, 85 to 90%, are then going to cross. So let's do a dashed line. It is then going to cross at the brainstem. And it doesn't, I kind of fudged it a little bit. So that is going to be that's the brainstem. So specifically, it is going to cross most of it at the medullary pyramids. Medullary pyramids. 85 to 90%. And this is going to be the lateral corticospinal tract. The lateral corticospinal tract is then going to descend, and then once it gets to whatever level, it is going to synapse on the ventral gray horn. So ventral gray horn, and then so this is the upper motor neuron. It is then going to synapse on the lower motor neuron. And then the lower motor neuron is going to go through the ventral root, and then it's going to go to whatever muscle. Let's generally just think about muscles for this. Okay, so that covers the lateral corticospinal tract. So the one that is 85 to 90% of the tract. That is the lateral corticospinal tract. So if there's a lateral corticospinal tract, that means there has to be a medial corticospinal tract. And yeah, some people call it that. Other people will call it the anterior corticospinal tract because it is going to travel through the anterior white column. So we'll do this in kind of a squiggly line. So this part does not cross at the medulla, so the medial corticospinal tract. It does not. However, at the level of the spinal cord, it is then going to cross and then go to the and then going to synapse on the lower motor neuron at the ventral great horn, just like that. So we'll do this kind of like a funky X and then put spinal cord, and then this is the medial corticospinal tract, and this is only 10 to 15%. And in terms of what kinds of muscles these guys innervate, so number one, lateral corticospinal tract is going to be most of your muscles, and it's going to be more of your limb muscles. And then the medial corticospinal tract is going to innervate the muscles closer to the spine, and that's why it's less. So yeah, that's corticospinal. And then while we're here, we can go ahead and talk about the difference between upper motor neuron damage and lower motor neuron damage. So if you damage an upper motor neuron, that is going to, they're both going to cause paralysis, but this is going to be spastic paralysis, versus lower motor neuron, that is going to be flaccid or flaccidic. So spastic versus flaccid. And then if you're doing reflexes, upper motor neurons, if they have an upper motor neuron lesion or something going on with the upper motor neuron, the reflexes are going to be they're going to be hyper reflexive. So instead of it being a 2+, it's going to be a 3+, 4+. And then there's also a lot of upper motor neuron tests you could do, like the Hoffmans, like Babinski, like Clonus, Shimizu. There's going to be a lot out there that can, lead you down that road. And then lower motor neuron, they're going to be hyporeactive or hyporeflexive. So instead of a 2+, they're going to be a 1+ or a 0. You're not going to be able to elicit that response, that reflex. Those are the main differences between upper versus lower motor neuron. Yeah, I feel like the only thing left to do is really apply all of these. And that is going to be with one of the more difficult spinal cord injuries that we could talk about, and that is a Brown-Séquard. So we're also going to talk about Brown-Séquard lesions here. So let's draw a little spinal cord. So brain, spinal cord, and let's say this guy has a lesion at, let's say T3, and it's on the what side is this? So right and then left side. So left side on left. So that's the lesion. He has a T3 Brown-Séquard lesion on the left side. So Brown-Séquard, so that just means half of the spinal cord is affected. So there's some sort of lesion here, and that's going to stop messages coming down, so your motor tracts, and then messages coming up, your afferent. But which one? Well, since we started with DCML, let's start with DCML. So DCML from the right, let's see what happens. So DCML from the right, so there's that, and then it doesn't synapse until the second order neuron till the brainstem, and it doesn't cross until the brainstem. So it's just going to stay straight, cross, and then it is going to go to the brain there. Now, keep in mind, it's not just one long neuron here. So it synapses there, and then it gets sent to the thalamus, and then the thalamus sends it there. So the first order neuron, second order neuron, third order neuron. Okay, so let's keep a list of good things on this side. Actually, we'll only write the things that are affected. So right DCML, or let's not say that. Right detailed touch is fine. Okay, right detailed touch is fine. Okay, so So right detailed touch is good. Let's see about left detailed touch. So DCML, it's going to be picked up here, and then it's going to try to meet with its second order neuron. Oh! So, things that are affected, so negative. So, detailed touch on left. That is affected, okay. I accidentally moved the whiteboard. Can you still see that? Yes. Okay, so now let's do spinophalemic, and let's start on the right side since that's what we did for DCML. So we pick up the crude touch, or pain and temperature, whatever you want to say, spinophalemic, and then it crosses at the level of the spinal cord because, you know, it synapses with the second order neuron at the substantia gelatinosa, and then crosses via the anterior commissure, anterior white commissure, and then it travels up to you know, travels up, oh, but it gets knocked out. So, crude touch, and then what you really think about is pain and temperature on right is affected. Or if we're talking about dermatomes, light touch was affected on the left, and then pinprick was affected on the right. And then let's talk about the left side. So the pain and temperature message gets sent in, and we synapse with the second order neuron, then it travels up, and then it synapses at the thalamus, and then it gets sent to the primary sensory cortex. Okay, so on the left side, spinophalemic is good. Okay, and last but not least, we got corticospinal. And for simplicity, since the lateral corticospinal tract is most of the tract, let's just assume that it's 100%. It's not, but let's assume. So primary motor cortex, that's where we start. That's where the neuronal cell body is for the upper motor neuron. It travels through the internal capsule. It crosses. Well, I don't want to show it crossing all the way up here. It stays here, and then it crosses via the medulla, and then it goes down. Oh! So if you're a muscle on the left after T3, you're not getting innervated. So muscles on left are not innervated, okay? What about over here? So if we're starting on the left side of the brain, that means we're going to the right side of the body. So we travel through the internal capsule, and then at the medulla we cross, and then and then once we get to whatever level we are, we synapse with the lower motor neuron. It exits through the ventral root, and then we go to whatever muscle we're talking about. So the muscles on the right are innervated. Okay. Whew, that was a lot. So if you have a Brown-Séquard lesion, what is affected? So detailed touch on the same side as the lesion is affected. Crude touch on the opposite side is affected, and then muscles on the same side of the lesion are affected. Now, what we also need to consider is that is only at the level of the lesion and below. If we're talking about muscles above the level of the lesion or sensory above the level of the lesion, it's not going to have that issue. That'd be like if you're traveling I-75 or whatever interstate you want to talk about, and there's a traffic jam at exit 29. Exit 29 is jammed, but you're only going from exit 11 to 15. Exit 11 and 15, you can go back and forth from all day long, and you're not going to meet that traffic jam. That's what Brown-Séquard is. It is a traffic jam. And if you're above it, then you're just going to go, you're not going to have to deal with it. But if you're at the level and below, you're going to have to deal with that traffic jam. If the traffic jam is off exit 29 and you have to go north, and that's where the jam is, then you're going to have to try and go through it, and good luck. So yeah, that was a little application. We got to talk about Brown-Séquard, and we got to learn about the 3 main tracts. I appreciate your guys' time. Feel free to ask me any questions you got. Thank you very much.